All right, to kind of close out our lesson on synthetic division, I have a little theorem here called the remainder theorem. And the remainder theorem used to be a really valuable, really kind of worthwhile theorem. In my personal opinion, there's not as much need for it nowadays that we have good calculators and everything, but it's kind of a cool historical result, which I'll show you guys just so you've seen it. I'm not going to emphasize this very much, though. It'll happen like once on the homework and probably not on a quiz. But just see it so you know what's going on. Basically what it says is if you're doing synthetic division, kind of a cool consequence of synthetic division is that the remainder you get when you do your division is going to be the answer you get if you would plug the root into the problem. So say I gave you this equation right here, and I asked you to find f of negative 2. Now, if I asked you how to do this on a test, like a normal person, you'd probably just plug in a negative 2 here, here, and here, pop it in the calculator, get your answer, and move on with your life. And that's fine. But when calculators weren't as good, this was like a shortcut that would let us still do the problem. So, obviously, like I said, you plug this into the calculator, and I'm even going to show you right here. If you type the whole thing in the calculator like you would expect, it's supposed to equal 132. And that's how you would really want to do it. But the remainder theorem is a cool consequence. I'll show it to you just the once. You'll do it on one homework problem. And like I said, probably never again. If there's a negative 2, we're going to put the negative 2, the thing we want to plug in, we're going to make that what we divide by. That's our roots. And we set up our synthetic division like normal. So we have our outside right here, just like we always do. And we're going to power through and actually do synthetic division on this guy right here, which you guys have gotten pretty good at, I'm sure, by this point. I'm kind of flying through the numbers just to hurry up and get an answer on this one. So we got negative 56 and plus negative 9. We get a negative 65 here. And when you set this up in the end, the remainder happens to be what you get when you plug it back in. So it's kind of a cool concept. It's interesting that it works, and the math behind why it works is worthwhile. But practicality-wise, like, you're not going to use this very much. But if they ever ask you to use the remainder theorem, like I said, it happens once on the homework. If you do synthetic division with that number, the remainder is what you would get by actually plugging it in. So kind of a cool little thing.